Hello, today we're going to talk about Topic 1, Section 9, Laws of Logarithms. So I'm going to run through all the examples and section problems off of Cognity. Now, for example 1, this we can just see off the bat, 2 to a number is supposed to give us 3. Well, we know that's not going to be anything nice because 3 is not a power of 2. Okay, so what we can do is write it as a log by doing a loop-de-loop. So we get log base 2 of 3 equals x. Now, we got that based off the numbers we hit in our loop first. So we hit the 2, then the 3, then the x. So we wrote it in that order, 2, 3, x. All right. Now we want to put this into our calculator, right? We said x was not going to be something nice, so we should use our calculator. Off of your calculator, you should have a button that is a log button that is written as base 10. So you need to be careful that the log button is typically just base 10. Now, depending on which calculator you have, you can change that base. And every calculator, of course, has a different way of getting to that. So if we want to write it with a log of base 10, we can actually rewrite this as log base 10 of 3 divided by log base 10 of 2. That's the same thing. So if we want to put that into our calculator, we would do log 3. Notice how it put a parentheses. We close it. Divide by log 2 in parentheses. Enter. There we go. We get about 1.58. All right, if we do 3 significant figures, 3 sig figs, 1.58. Now, of course, we have fancy graphing calculators, so we are going to utilize those. And how we can get to the log with a different base is you press the math button. You go all the way down or up and go to log base. It's the A. And here we can write a different number. So I'm going to write 2. Ooh, too many. Delete. Okay. And then go to the right, hit 3, enter. And notice I get the exact same number. Okay. So if you don't remember where it is, do division. Hopefully you remember where it is because I know a lot of people forget that division. Okay. So 1.58 is your rounded answer. So make sure you know the difference. Here it just said find the value of x. So if I said the exact value, I would mean this, log base 2 of 3. If I said the rounded answer, I would tell you how many sig figs or decimal places, and you'd give me about 1.58. Okay? Know the difference between the directions there. All right, so let's go down to the second example. Here, it says we have to do this without using a calculator, okay? I am all for using your calculator. I will show you every shortcut I find. I will help you know the ins and outs. But some things you got to do on your own. You will be tested on some things on your own, okay? So this is a lot easier than you think. Set them equal to x. We don't know what they equal, so set it equal to x. Now look what you have. You have log equals something. Do your loop-de-loop. We rewrite this one. We get 3 to the x power equals 1 over 9. Right? We put our numbers in order. So 3, then the x, then the 1/9. So we're doing exponential. 3 to the x equals 1/9. So hopefully you know that means x is just -2. Negative makes it a fraction. Okay? All right, the next one, we do another loop-de-loop. We get 4 to what power equals 64. That's supposed to be an x. So hopefully you know that's just 3. Okay? Easy peasy. Lemon squeezy. Okay, anyway, so the next one. So this tends to confuse people just because there's so many things over here. Notice this A on the left side, that's the base. This part is the argument. So that gets stuck together. So here, when we do our loop-de-loop, the little a goes here with the x. Then it equals that thing in parentheses, a to the m. And hopefully we know that has to be x equals m. All right, a to the 15th power has to be equal to a to the 15th, right? You can't raise it to two different exponents and get the same number. That's not going to happen. Okay? Let's keep it rolling. All right, example 3. Again, evaluate these without using a calculator. It looks weird. There's a lot of variables. I know it's scary, but trust me, you can do this. First thing we're going to do is add it equal to x. Okay? So, start with the first one. Let's do a loop-de-loop. A to the x equals 1. So remember, we're solving for a. All right? So a to what power equals 1? Well, a has to be 1, right? 1 to the first power, 1 to the 5th power, 1 to the 100th power, right? Okay, so now we want to know what x is. So a to what power has to be 1? Okay, so maybe the a is throwing you off, so maybe just put in a number, okay? So 5 to what power has to equal 1? Okay, well, maybe that makes it easier. X has to be 0, right? We don't know if it's actually 5, right? So this really is anything. All right, so x has to be 0. Okay, let's keep looking at it. Okay, so here we have it in exponential form. This is a to some power equals x. So this is exponential, so we need to write it into log form. Okay, so we get log base a of x equals log base a of m. Huh. Wouldn't you know? A, x, log base a of m. Well, just like with exponential in the last one, x must equal m. Okay, so that's a nice little trick there. A to the exponent of log base a of m is going to equal that m. Okay, that's going to come in handy later. Okay, so here we do another loop-de-loop. I'll change my color. Okay, so a to what power must equal a? Well, x must equal 1. Okay, a to what power must equal a? All right, one more. This is exponential. E to what power equals x? So we rewrite it. Log base e of x must equal the natural log of m. Well, hopefully you realize those are the same thing. That's the natural log of x equals the natural log of m. So x must equal m again. Okay, so this is I'm hoping this is helping you see the properties a little bit more. Okay. All right, let's see, section questions. Okay, so for the first one, we can evaluate these separately, right? Because this one has a different base than this one. This is log base 10. This is log base 5. So we can't actually add them. So think about them separately. Log base 10 of 100, well, what does that equal? That's just 10 to what power is 100? So that is just 2. So this part is just 2. Then we have plus. So plus. And then we have log base 5 of 125. Well, what does log base 5 of 125 equal? 5 to what power is 125? So x is just 3. So this part equals 3. So our answer is just 5. So here we're able to do it without a calculator. Now by all means use your calculator, double check yourself, but you know, I can't notice if you guys are using your calculators or not, right? You guys are working from home. So just do that for yourself. Just know that there's going to come a time at the end of this year, all right? There's going to come a time when you're taking this test for AI, and you'll need to know how to do this by hand, okay? It's not that hard. Trust me, you can do this. It just takes practice, okay? All right, let's keep working. All right, so this one, okay? So maybe again we're confused. We're like, whoa, I have no idea. That is the weirdest thing ever, okay? Maybe, I'm telling you, it's a mu alpha theta trick, upper level trick. Set it equal to something. We don't want to use x because we already have x over here, so I'm going to let it equal y. This is exponential. 5 to what power equals y? So if it's exponential, we're going to write it as a log. Log base 5 of y must equal log base 5 of 3x minus 4. Well, look at that. We now have log 5 equals log 5. We can chop those off. We get y equals 3x minus 4. And that's it. We can't do anything else. It's 3x minus 4. We don't want to put it to the other side because we don't want to put y in our answer because we invented it. Since we created it, do not put that in our answer. So this, you simplified this whole mess, is just equal to 3x minus 4. And again, that was our shortcut from before. When you have an exponent and it's the same as that base of that log, these basically cancel each other out. Okay, that's a shortcut. Okay, so let's keep it going. Let's do this one. I don't know what it equals. Set it equal to x. This is log form. This is my argument, because my 1/3 is my little number. Do my loop-de-loop. It's log, put it in exponential. 1/3 to what power is going to get me 1 over 81. Ah, that's a lot easier to see now, right? Hopefully you got that one, and that's just 4. Okay? All right, so logarithms can be simplified by using these properties. Okay, so if we're adding logs that do have the same base, so notice it's a, log base a minus log base a. Okay, when we have the same base, we can combine them. When you add them, you multiply. When you subtract, you divide. It's basically the opposite of exponents, okay, because logs are the opposite of exponents. I know, it's weird. All right, so exam tip. These are going to be on your booklet, so you don't have to memorize them, but you should understand how to use them. Okay, and you will only be asked when to manipulate them in base 10 and base E, which is nice. All right, we're of course going to practice it with more than just base 10 and base E because I want you guys familiar with this. All right, you've done it before. So this one, they have the same base. Okay, that's step 1. You've got to make sure they don't have the same base. You can't do this. So it's addition. So we're going to multiply. So we're going to do log base 7, and you're going to do xy squared times 1 over xy. So now we can combine them. The x's cancel because you get that over 1. Okay, the y's also simplify, so we get log base 7 of y. There we have it. Now, if you're unsure, if your numbers kind of blend and you want to make sure that I know this is your argument and this is your little number, okay, because maybe you write your numbers pretty big, you can put this in parentheses. Okay? I just know some people have those big bubbly letters or numbers. All right, so if you want to make sure that this is your argument, put it in parentheses. Okay, so given that log this and log that, find the value of log base d of 2. Okay, cool. I want to find log 2. Well, I know what log 5 is. Okay, so I know log 5, and I know log 10. How can I manipulate those to get a 2? Well, the only thing I can do with logs is I can either add them or subtract them. Well, remember, if you add, you multiply, and if you subtract, you divide. So I want to figure out a way to make 2 happen. So I think, hopefully you don't have to think for too hard or for too long. You do log 10 minus log base d of 5. And we should get log base d of 2. Because when we subtract logs, we divide them, right? 10 over 5, which is log base d of 2. So that's how we know we did it right. Okay? So notice what we've got here. Log 10 minus log 5. So log 10 is 11 minus log 5, which is 8. So log base d of 2 must equal 3. All right, kind of some plugging and chugging. Not plugging and chugging, more like substitution, right? Because we have to plug in things we didn't know. Okay, substitute stuff in. All right, example 3. So here we have log A, log B, log C. We want to evaluate, all of this jazz. Well, I don't like that it's all together, so let's separate it. Okay? First things first, I know that I have a division, so reverse that, reverse those logs, and you can write it as log of a squared c minus log cube root of b. Right? If we subtract the logs, we divide with the arguments. Okay? We're basically working backwards. Okay? Then I have multiplication right here. Oh, let me change my color. We have multiplication right there. So we can rewrite that as addition. Log of a squared plus log of c minus log cube root of b. All right, well now I'm getting somewhere because now I have that log c, but I need log a by itself and log b by itself, but I've got these pesky exponents. What do I do with those exponents? Anybody remember? Yeah, I know. All right, hopefully you remember they go out front. So this is going to be 2 log a plus log c minus, how do I put a cube root out front? All right, got to write it as an exponent. Log of b to the 1/3. Then we put the 1/3 out front. Okay, if you don't remember that, that's in the next lesson, okay? So 1/3 out front. And we get this. And now we have log a, log c, and log b. And we can substitute our 2, our -6, and our 3 in there. Okay, so we do 2 times log a, which is 2, plus log c, which is 3, minus 1/3 b, which is -6. So we get 4 plus 3 plus 2. So our answer should be 9. All right. So this one, we're going to rewrite it as a single logarithm. Now here, well, first things first, I can't really combine anything because I've got numbers out front, so I'm going to rewrite those. The natural log of a plus the natural log of b cubed minus the natural log of c to the 12th. And then we just do exactly what they say. The natural log, you do a times b cubed divided by c to the 12th. So that's not how we write it, of course, okay, but that's what we're doing. So we're going to get ab cubed divided by c to the 12th. And there we have it, a single logarithm. It's the natural log of that. Nothing else out front, nothing else at the end of it. It's just log of something. Okay, so let's see, right? Log 5 plus 4 log 2, is a single logarithm. Same thing. Move your exponents first. So we get log 5 plus log 2 to the 4th minus log 4. Now we can write it all out. We get log 5 times 2 to the 4th. So 2 to the 4th is 16. And then we subtract 4, so we divide by 4. So 5 times 16 divided by 4 is 20. So single logarithm, log 20. Next one, we have log x, log y, log z. Ugh, another gross one here, so we separate it out. Okay, so we're going to have log base 3, and I'm going to do y cubed square root of z minus log base 3 of x to the 4th. All right, again, I got rid of the division first. And the next thing I like to get rid of is the multiplication. So I can write that as addition. So we're going to get log base 3 of y cubed plus log base 3 of the square root of z minus log base 3 of x to the 4th. Then move your exponents out front. So we get 3 log base 3 of y plus 1/2 log base 3 of z. All right, write that as 1/2 because that's a 1 there, 2 there. Again, we'll cover that next section in case you forgot. And then here we put the 4 out front. And we can replace. So log base 3 of x is 0.5. So this becomes 0.5. Well, let me just do it in order. That makes more sense. Log base 3 of y is 3. Plus 1/2 log base 3 of z is -2 minus 4 times 0.5. So we get 9 minus 1 minus 2. So our answer is 6. Perfect. All right. Excuse me. All right, write it as a single logarithm. So now we're just going to smash it all together. So here we first need to move our exponent. So log base a of r squared minus log base a of r to the 5th plus log base a of t. So we have log base a, all the same base. So we do r squared divided by r to the 5th, all right, plus t. Sorry, I guess we can do that as 1 if you'd like. So times t. So if I do r squared over r to the 5th, that's going to simplify to 1 over r cubed. And when we multiply the t, hopefully recall that the t is going to go on top. So we have log of t divided by r cubed. And that's your answer. Okay, so given that log p, log q, blah, 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 figure out what this is. Okay, so separate it with division and multiplication. So I'm going to do it in one step this time. So log a of a plus log a of p squared minus log a of q. Okay, because it was times the a and the p squared, and we were dividing by q. So we get log a of a plus log a of p. Well, that squared goes out front, so it becomes 2 log ap minus log a of q. Okay, so now we can just replace things. So here, well, I know the log base a of p is 1.2, and I know log base a of q is 3, but the log base a of a, I don't have one over there. Hopefully you remember, think about it, log base 5 of 5, that's going to equal 1, right? Log base 10 of 10, put it in your calculator, real simple, log 10 is 1. So this is just 1. So we get 1 plus, what is that, 2.4 minus 3. So we should get 0.4 for the answer. Okay, so given that log x, log y, find this one. Well, let's see, I would rewrite this as, it's so weird that they put logs with these problems before the rational, but we'll do it. So log base a would be x to the, well, the square root of x squared, hopefully you know that is just x, and the square root of y to the 6. All right, again, we're taking out pairs, so y to the 6 is 6y's, so we group them up. We're going to have 3 y's on the outside, so that's going to be log base a of x y cubed. Okay, so we can simplify our radical. Okay, so we actually didn't even have to write any rational stuff, so that's perfect. Then here we can separate those, so we get log base a of x plus log base a of y cubed. So we write it with 3 out front. And then we substitute. So 0.8 plus 3 times 0.4, 0.8 plus 1.2. Answer's 2. There we go. Okay, so this is what you should know by the end of it. Okay, so knowing your algebraic expressions, how to simplify them without using your calculator. All right, now there's one problem that they didn't really go over, and I would like to kind of talk about that. This one, I just know it might throw some people off. So here we have log A and log B, but then it wants us to find AB. Okay, so instead of having log A and log B, maybe we should rewrite them as A equals and B equals. So do your little loop-de-loop. We get x to the third equals A. We do our loop-de-loop here. We get x to the fifth equals B. So substitute those in. A times B, we'll do a different color. So A times B is just x cubed times x to the fifth. And that's just x to the eighth. And it was supposed to equal AB equals this. So this equals x to the p. So 8 equals p. Okay, and that's what we found. All right, so hopefully that helps you with the cognitive assignments. If not, you know where to find me. All right.